Okay, friends. So here's a couple graphs that I've dug up in the news media over the past couple of years. There's a bar graph showing percentage of students that are earning high school diplomas, ostensibly in America, from the Department of Education. So you've got 75% in 07-08, and it's slowly a little bit of a hump here, and then it rises up to 82%. So it looks like we increased by about 7% over that time period. Alrighty. And then down here, we've got Democratic women raise less money than Democratic men, which is true by looking at this graph, assuming that the source from Responsive Politics is actually true. Women looks like they're pulling in about 1.4 million on average per, and men are pulling just shy of 1.6 million. So the men are pulling in about 200 grand more on average per man than the women candidates are. Okay, so the first question I ask is, what's misleading? And then I give you a little bit of a hint. If you look at the vertical axis, what is misleading about the vertical axis? So let's look at this one first up here, even though some of you might say, well, there is no vertical axis there. I mean, there's nothing showing right here, except there doesn't have to be, because you've got the numbers sitting on top. If you think about what a vertical axis does, for example, this graph here, this one does have a vertical axis. But since these numbers are on top of the bars, there's really no reason to have the axis at all. You could just cover that axis up and you'd still be able to read these graphs. So it's nice that they have the axis, but it's unnecessary. And you'll see this with bar graphs sometime. I actually did it up top with the Blackboard journal turn-in graphs. I mean, I didn't have a vertical axis, but the numbers were sitting on top of the bars, so you could still tell what was going on. So let's just look more closely at these bars. 2007, 2008. It's 75%. Okay, fair enough. It's also a stack of books instead of a pure bar. This is technically called an infographic. So what an infographic is it's a bar chart most often that has kind of cute little icons that stand for the theme of the data. So this data is about graduation from high school, so they're using books to stand for that. Okay, so I noticed that there are 5 books, and it looks like they use kind of the same 5 books for the first place of every bar. Okay, so let's do some math. If you've got 75% in this stack and there's 5 books in that stack, that would mean that each book is 15%. 15 plus 15 is 30, plus 15 is 45, plus 15 is 60, plus 15 is 75. Okay, I'll buy that. Looks like it's also that way in 2008, 2009. All right, so 15, 15, 15, 15, 15. Let's go over to 2009, 2010. So if we keep the same 15% from the books, we go 15, 1, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150%. There are 10 books in that stack right there. 10 books. That means that there are twice as many books in this stack as there are in this stack. How can it be that twice as many books in this stack as this stack, but that's only 3% higher? What's going on? And it gets worse. Look over here. Look over here. This pile only adds up by 1 extra percent, but it adds a whole bunch more books over here. So what's going on? How did they get this graph? We'll come back to that in a second. Promise. Promise. Let's look, because the same mistake was made here. If you look at this bar right here for the female candidates is $1.4 million tall. Well, if that's true, then that same vertical height here should be 1.4 million vertical dollars. Which means if you added that again here, that would be another 1.4 million vertical dollars, which would be 2.8 vertical dollars. And then it looks like you could almost even add another one up here, which would be another 1.4 million dollars, which would be 4.2 million. So if this bar here is about 3 times as big as this bar here, why isn't this number 3 times as big as this one? What I'd like to do is now get into answer number 8 down here. which on this graph paper you've got, we included a little piece of graph paper here. I'm going to stop this video right now, and I'm actually going to record a hand-drawn graph. We'll eventually show you how to do these using sheets as well. I might even add a sheets video at the end of this one. But I'm going to do this next one hand-drawn using that piece of graph paper right there. And we're going to use the second graph because it is going to be definitely easier to use this second graph than the first one, because you only have to draw 2 bars here versus these 7 bars up here. So let's take a quick little pause, and I'm going to show you, by drawing the graph correctly, kind of how they cheated it here. Let's check it out. Okay, friends, you know what? As I was getting the camera ready to record me drawing on pencil and paper, I said, you know what? This is a great time for us to just get into sheets. Let's just learn how to make a graph in a spreadsheet. How's that sound? So go online, go to Google, type sheets. What we're going to do is we're going to get you into a free online spreadsheet that you can launch from your computer at any time. Now, I have a Gmail account for this class, but you do not need to have a Gmail account to create a Google Sheet. So all I'm going to do is I'm going to click on this. Now, this is the sheet that you come to, or the page you come to, I should say. And we're just going to go to Personal. And for free, we're going to create a Google Sheet. So when you go here, I don't think you'll see all this stuff down here, because this is stuff that I've been making in my Google accounts. So you're just going to go to blank for a new spreadsheet. And what you're going to get is you're going to get something that looks like this, which is essentially a grid. It's got horizontals and verticals. You've got columns that are lettered, and you've got rows that are numbered. All right, and we're going to spend a lot of time in spreadsheets in here. But what I'm going to do here is really simple. We're not going to do a whole bunch of function work. We'll do that later in a later video in this section. Instead, let's just set up a bar chart representing this exact same data that we saw over here. So in this bar chart, we've got 2 candidates, female candidates and male candidates. So back to our little spreadsheet, and I'm just going to pick any old cell over here. I'm just going to click here. It doesn't matter which one you click in. Female candidates. Let's spell that right, shall we? Candidates. Okay, and then press enter, and then male candidates. So I just type that in. So I just put that in this column right here. One thing I'm going to tell you right now, you see how female candidates, the words kind of go past the bars. You can double click up here and it'll make the bar wide enough for all those to sit in. All right. Now that's going to be the left column of a 2-column table that we're going to graph and turn into a chart. The right column is going to be the dollar amount. So I'm going to title the column, though. I believe it was the average campaign, was it contribution? I forget. Average campaign, average raised by average raised. We're just going to we'll change campaign to average raised. That's good enough. All right, raised. All right. And I spelled raised wrong. My goodness. Raised. Boom. Okay. And for females, I'm going to put a $sign. It was $1,400,000. And for males, if I remember correctly, it was $1,585,000. So that if you do that, it formats it as money. So that's the same data that is in this bar chart right here. $1,400,000 for female candidates, $1,585,000 for male candidates. And this is what's so slick about Google Sheets, is Google Sheets is able to very, very quickly create a chart or a graph from this. So what you're going to do is you're just going to select all that data, including the little average raised up there. And you're going to go up here to Insert. And you're going to go down to Chart. And that is exactly what we want to see. It predicted what kind of graph we wanted. And that looks, if you look at it, that looks an awful lot like this graph. This one's a little fancier. It's got these weird little, I don't know what the heck these little horizontal things are on that little diagonal line. I think somebody got a little too creative. So the bars are still there. So let's go back to that sheet. There's our graph. Notice up here, it's got a title. It pulled the average raised from over here. I'm not entirely sure why that little verses up there shows up. You can just click in it, click again, and then type, delete, get rid of that. You can also go in here and edit that title by typing something else. You know, you could put average raised by primary winners if you wanted to get a little bit more specific, okay? But really what I want to focus on is I want to focus on this, because this represents 1.4 million. And if you hover over it like I just did, it actually pops out. Average raised $1.4 million. And for males, average raised is $1,585,000. This bar is almost the exact same size as this bar. So how can this graph look so different than this one? And in case you're not seeing it, the answer is right here. That's what's causing the difference. Look at the lowest point on this graph. It's $1.3 million. What's the lowest point on our Google Sheets chart? 0. So what they did to make their graph is they took a screenshot, I'm going to do it too, of this, and they cut it at $1.3 million, which is right about there. So that's what they're having you look at right there. And when you look at it that way, yeah, this looks about 3 times as big as this. Even though the numbers are on the graph, it says $1.4 million and $1.585 million. But what they've done is they've left all the distance down to 0 off, and they're focusing only on that. Well, that's not fair now, is it? If you're going to make a bar represent $1.4 million, then the whole thing represents $1.4 million. And this whole thing has to represent $1.585 million. And that's the problem. So I guess the question now is, why did they do this? Well, I have a theory as to why they did this. They want that difference to look more extreme than it actually is. They want to really drive home the point that the male candidates are earning, quote unquote, so much more money than the female candidates. Now, $200,000 is a lot of money. I'm not saying it's not. But they're not earning 3 times as much as the female candidates are. They're only earning, I would say, what's $200,000 into 1.4? It's about a seventh, right? So they're earning about 14% more. This is not 14% bigger than this, which is 3 times as big. So I think when they cut the vertical axis where they did, they're trying to make this very fair looking graph right here look like this very unfair looking graph right here. They're hiding 0 from you. Just so you know, the exact same thing happened up here with the book graph. Exactly the same thing. If you look at where 75 is here and where 78 is here, it's pretty clear that this distance right here is 3%. If I had to guess, I think the bottom of this graph is somewhere around 72%, which would look a lot different if you had this drop all the way down to 0. And I encourage you, if you want some practice doing Google Sheets charts, I mean, if you have some time to kill, I would actually enter all these in to Google Sheets and enter these percentages in and do like we just did with this one and create a bar graph. And you can see Google Sheets will do it right. It'll bring it down to 0, just like this one. So that's the lesson. And you're going to see this a lot as politicians try to get your votes and your money. They're going to consistently and constantly start those graphs at something other than 0, which is going to turn a very, very fair graph like this into a very unfair graph like this. Cool. I hope that helped. Let's do the next few.